Real numbers and algebraic expressions. This is Unit 1 of APA course or Applied Algebra. There are 5 objectives in this unit, and we are going to discuss each objective. Objective number 1. Ordering real numbers using the number line and inequality symbol. Example number 1. Plot the numbers on a number line. The numbers are 3/5, -2.4, 2 1/5, square root of 7, and -5.4. It is easy to compare the numbers if we are going to write them in decimal notation. So 3/5 is 0.6, 2 1/5 is 2.2, square root of 7 is 2.6. So the smallest here is -5.4, then -2.4, then 3/5, then 2 1/5, and square root of 7. So we can arrange these numbers from the smallest to the largest using an inequality symbol like this. So it's -5.4 less than -2.4 less than 3/5 less than 2 1/5 less than square root of 7. Now we are going to plot these numbers on a number line. So this is our number line. So -5.4 is somewhere here. Then -2.4 is somewhere here. Then 3/5 or 0.6 is somewhere here. Then 2 1/5 or 2.2 is somewhere here. Then square root of 7 or 2.6 is somewhere here. Objective number 2. Identify the bounded and unbounded intervals and inequality symbols. Example number 2. Graph -3 less than x less than 2. So this is our number line. -3 is here, so we are going to put an open circle. Then 2 is here. We are also going to put an open circle. Why open circle? Because the symbol here is just less than, and also here is just less than. And then we are going to shade this part between the two numbers. So this is the graph of -3 less than x less than 2. How about if we are going to change this inequality from less than to less than or equal to? So for our example number 3, we will do that. So that's -3 less than or equal to x less than or equal to 2. So this is our number line. This time we are going to put a closed circle on -3 and also a closed circle on 2. And then we are going to shade the part between the two numbers. So that means if it has a line under or it's less than or equal to, it's a closed circle, while if it is just less than, it's just an open circle. Example number 4. Graph -5 less than or equal to x less than 6. Here we are going to put a closed circle on -5 and an open circle on 6. So again, this is a closed circle because this is less than or equal to, and on 6 we have an open circle because it's just less than. Then we are going to shade the part between the two numbers. How about if we are going to switch the inequality? So this time, for our example number 5, we are going to graph -5 less than x less than or equal to 6. So this is our number line. We are going to put an open circle on -5 because this is just less than, and then we are going to put a closed circle on 6 because it's less than or equal to. Then we are going to shade that part between the two numbers. So this is the graph of -5 less than x less than or equal to 6. This time we are going to talk about unbounded intervals. So example number 6, graph x is less than 3. So because this is less than, we are going to put an open circle on 3. And because it's less than, we are going to shade that part that is on the left of 3. So this is the graph of x is less than 3. How about if we are going to change this inequality symbol from less than to greater than? So this is our example number 7. So this is our number line. Again, we are going to put an open circle on 3. Then because it's greater than, we are going to shade the part that is on the right of 3. And our graph looks like this. Example number 8. Graph x is less than or equal to 1. Now here, the symbol is less than or equal to, so that means we are going to put a closed circle on 1. And because it's less than or equal to, so we are going to shade that part on the left of 1. So this is the graph of x is less than or equal to 1. How about if we are going to switch our inequality symbol? We are going to have it x is greater than or equal to 1. So this is our number line. Again, we are going to put a closed circle on 1. Then because it's greater than or equal to, we are going to shade that part that is on the right of 1. So this is the graph of x is greater than or equal to 1. Objective number 3. Determine the absolute value of a given number. We have here example number 10. Evaluate the absolute value of -3 plus the absolute value of -6. So the absolute value of a number is the positive of that number. So this means the absolute value of -3 is 3, and then the absolute value of -6 is 6. So we have here the absolute value of -3 plus the absolute value of -6 becomes 3 plus 6, and 3 plus 6 equals 9. Example number 11. Evaluate negative of the absolute value of 10 minus the absolute value of -11. So the absolute value of 10, which is positive, is still 10. So we have a negative sign here, so that's -10. Then minus the absolute value of -11 is 11. So we have -10 minus 11, and that is equal to -21. Objective number 4. Define and evaluate algebraic expressions. Example number 12. Evaluate 3x squared minus 2y if x equals 3 and y equals -2. So this is our algebraic expression. Algebraic expression is a math expression that uses numbers and letters or variables along with operation symbol, plus, minus, multiply, or divide. Now here in this problem, we will just substitute x with 3 and y with -2. So it becomes 3 times 3 squared minus 2 times negative 2. And 3 times 3 squared is 27, and negative 2 times negative 2 is positive 4. So we have 27 plus 4, and it is equal to 31. Example number 13. Evaluate the quantity a minus b squared plus c if a equals 2, b equals 5, and c equals negative 1. So this is our algebraic expression, the quantity a minus b squared plus c. Now we are going to substitute a with 2, b with 5, and c with negative 1. So we have the quantity 2 minus 5 squared, which is equal to 9, because 2 minus 5 is negative 3, then square it, that's 9, and then minus 1. So 9 minus 1 equals 8. So this is our answer. Objective number 5. Identify the properties of real numbers. Example number 14. What property is illustrated in x plus y equals y plus x? So notice here we are adding 2 letters and we just change the order. So this property is called commutative property of addition. How about example number 15? What property is illustrated in x times y equals y times x? Notice here that we are multiplying 2 letters, x and y. We only change the order. So this illustrates commutative property of multiplication. Example number 16. What property is illustrated in the quantity a plus b plus c equals a plus the quantity b plus c? So notice here that we are adding 3 letters, a, b, and c. On the left side, we have in quantity the a plus b, while on the right side, we have b plus c in a quantity. So notice here that we are just regrouping the 3 letters. So this illustrates associative property of addition. Example number 17. What property is illustrated in the quantity a times b times c equals a times the quantity b times c? Notice here that we are multiplying 3 variables, a, b, and c. On the left side, a and b are grouped together, while on the right side, b and c are grouped together. So this illustrates associative property of multiplication. Example number 18. What property is illustrated in a times the quantity b plus c equals a times b plus a times c? So notice here that this variable outside is being multiplied by b, which results to a times b, and also a is multiplied by c, which results to a times c. So this illustrates distributive property of multiplication. Thanks for watching, guys. This is teacher Rejil. Keep safe.